Testing. Welcome again to Wickerson Studios. My name is Michael Wickerson, and I'm continuing with a Rhinoscriptsyntax into the Ghpython nodes series. This last script that I end with in the vectors 2 file, GH file that I'll be sharing, basically has a very simple script here in the Python node, which I called the Rhinoscript vector length because that's basically what I was playing with. I did a little fudging and fiddling with it and made for an interesting geometric pattern of visualizing vectors, and you can see exactly what I did with a simple rotation. But it really is getting behind the visuals and getting into the geometries that really are directing what's shaping and forming things. And you can actually see within here there's some interesting bake happening on the point system. So if I actually rolled one of these through an animation, you'd see the points are being actually generated in my Rhino. And I think that's a very interesting thing I haven't seen anybody really do. I've been doing it myself recently. So I'll go in here and I'll animate in the Y direction as well, and you'll see once again it's playing off and altering my vectors. And I'm not recording my vectors, but I am recording my points. You can see what happens when it flattens the X and Y. But as long as you have that very interesting Z-axis, you get a pretty cool script that does some wonderful things. We'll end up getting there. Let's leave for a second this one, shut it down, and we'll take all of these and we'll move these 3 sections because we're going to be going into all these other, describing all of these other ones in Python nodes as we go through and try and do some more exciting things as we get going. But we wanted to know the basics, so we learned the basics of selection and inputs, and now we're into the vectors. And I'll frame this up afterwards. Let me just take this one and put disabled. And we'll get rid of what we baked in the Rhino. Make this one large. Maybe go up here because I think we're dealing in vector length, so everything can be seen probably in its perspective or top view. So just slide this one over. So the vector, the functions that I'm going through in vector script, the whole intention is to go into this, go deeper, find the kind of corollaries that are associated with them. But basically, you start with vector add point, and I'll just enable that one. And this is following up from the last video series, which was dealing with selection and inputs. So this one's called Vectors 002. So we'll go into here and we'll just hit preview on, and you can see what happens. We basically have a very small script, which I think you can make even smaller. Bring the Python editor down a bit. And you see I've plugged in my integer value, my type int integer. So you can right click here and you can go down to type int. Make sure it's in type int integer, integer for x, y, z, and then I have a multiplier that's a float. And pretty simple. Wrote it as 0.1, 0.2. Didn't want to hard code in numbers, but I wanted to bring them in as inputs into the node. And then the point is generated by point add in Rhinoscript. And I guess I was adding points, which was actually adding the point to the Rhino window. So what I wanted was a point add. Which is a different type of script that I guess doesn't bake it in while I do it. So interesting to think about that. So when I test it, I'm pretty sure the point isn't added in, and that's where it's been generated. So as I move this around, you're not seeing a bake. I should double check that just to make sure I'm making sense to myself. But you discover things as you go, and don't be happy with the simple little things that come out. So when you're in here and you're taking a look and you're typing in like Rhinoscript point add, and you hit the parentheses, and it tells you, okay, go in there and add 1 point and add another point. Well, think about how you can create those points and how you can use the examples. And even though the example here has hard-coded 1 on 1, 2 to 2, that's fine and dandy. It does tell you what you should see also: point compare, point divide, point scale, and point subtract. So we'll end up getting there sooner or later. We're just creeping through all of the Rhinoscript syntax functions, and we'll be putting them into their own functions in Python. What I am ending up doing is I'm probably going to have a function drop down or something up on the ribbon tool with Python, or I'm going to put it into my snippets. And it might be my 1001 Ghpython snippets. Why not aspire to that? Okay, so we'll close this one out, and the script's running, and it's defaulted. And we'll just take it to disable, and that one's done. The next one I did was I went in here and I guess I visualized some things. And this is a vector create. So when doing a vector create, you're going to have to go into display and find some way of doing a vector display. Let's turn it on and let's preview it on. And there it is. We've got 2 vectors that are regenerated here. Very simple. And instead of a float change. Well, it is a float change. It's very similar to the other one. I use delta just to be the symbol for the idea that it was actually a change in XYZ. I can run the script. Everything should run fine. I'm not sure why it's not. Let me just see what's going on. Test the script. Okay, first point, it wants me to... Okay, the first part of the script says it wants me to grab the point. So what I need to do here is I need to hashtag out shift, shift, quote, 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 and shift, quote, quote, quote. That way I'm only running the top part of it, and it's saying pick a point, pick another point, and then it will build a vector between those. So that's visualizing the Rhino, what I call the Rhino vector, and that Rhino vector is right here. So as we look at that, it might be good to go in the top view, come down here, we'll zoom in here, and we'll say, okay, what really is happening there? And I've got an amplification on it of 42. I don't need a huge amplification. We can go into the center. It's a little hard to see, but let's run it again. I'll pick my point in the center and one over here, and there it will generate that vector amplified by 12. So if I just set it to 1, you'd see the actual scale, but it's nice to amplify it. Sorry for my color being so ugly. I should probably just go into preferences here and grab these and just bring this one back into a nice rich blue, dark blue, and that might make for an easier way to see it. Let's see if that works a little better. Well, it's red if I don't select it, and it's like a pretty fuchsia blue if I do, and even then I can't really see that much better, but I'll just leave it off. So then, if I want to bring my quotes up here, that's going to remove it from the bottom. Now I've taken off the first, and now I'm dealing with my Python vector. And my Python vector is, my GHPython vector means it's coming from these sliders. So as I run that one, this one's actually being altered and changed because of what I'm doing in the Z direction, which it's hard to tell from top view. And once again, I've got this strange add point instead of point add. So you see what's happening is I'm baking in kind of strange points as I go and following it around. What I like about those points is I generate them. I think it's kind of fun to grab them. Maybe a lot of people don't do this and just grab and interpolate. And now just press enter. I can jump in there and I can grab that curve. And I think it's kind of an interesting curve because as I grab that and slide that out of the way, you see it moves that curve over here without the points. It's got this weird kind of rickety motion of grabbing and jostling and whipping around and doing these weird things. So you're actually discovering some very interesting geometries to pipe, which maybe you're interested in, maybe you're not. But it's just a way to kind of programmatically kind of draw with a little bit of creativity and freehand. Of course, that's a sense of discovery I think all of this is about. Not to be told what to do and not seeking the same tutorials, but it is a sense of discovery and creativity. So maybe you believe that, maybe you don't. It doesn't matter to me. Disable, and we'll close that one up. And then we'll go down to the next one, which is Rhinoscript Unitized, which is basically the exact same thing, but it makes it ×1. And so in enabling that and take it to, it's like the amplification doesn't really even matter. If you run into the script and you run it, it basically is putting it in there, and I can downsize it after. But what it's trying to give me on every case, this vector, if I take off this visualization and just drop, well, if I don't do the amplitude, if I bring the amplitude back down to 1, 1 to 1, it's always going to give me that unitized vector no matter what I end up building. So no matter what point I do, it's just going to give me a single unit. And you can check that for length and it would be fine. And of course in the Z it's going to look differently, but if we went over the perspective, you'll see that, well, probably best to just grab that and just say, let's get around that one. There it is. So as I move it, it's kind of, it still have to behave. Of course, it's hard to see in the Y and in the X how that alters, and in the Z, that's moving in different perspective views, but it's staying unitized at 1. So not too hard, not too tricky to figure that one out. But put it into your pipe and smoke it because you're going to be using it. And we're going to keep going farther into this. The next one's a vector angle, which is pretty cool because the vector angle, I think, is coming from 2 surfaces. So as I enable and go to preview on, I'm pretty sure it's a little more complex. So as we go in here, you can see what they were doing as the sample in Rhino developer site, I think it was pretty interesting, is they're saying, okay, we want to get a surface object. So what I'm going to do is just basically make one surface object here. I'm going to probably make another one here. And okay, and then this one I'm probably going to rotate, and this one I'll rotate this way. Oops. Try and get on the red. Just not at a great angle of it. Let's get on the red and slide it up that way. Let's pull it off in this direction. It's got grid snap on, which I hate. So basically we have two surfaces here. We'll go to ghosted. Actually, what we probably need to do, sorry for this, is just get into the layers and pull it off that awful layer and put it back into the default layer, which should make it, that was the color of that. Hang on. Why is it at that ugly color? Black, white. Anyway, I'm just fudging around here for no good reason. We'll just deal with it. I could change the layer if I wanted to. But anyhow, I've got two layers. So what it's going to say as I run this script, you'll see I've just added a little b down at the end, and you'll see why. Let's pull this up here. I've got A and B. Let's see what happens when we run it. It's going to say select surface 0 and select surface 1. And there we go. In doing so, it has now generated two out angles, saying one angle is at 41 degrees, and now they're in degrees, and one is at 138 degrees, 0.5. It's actually separated those into A and B because I wanted to see the vector angle on A, and then I wanted to see the vector angle, reverse angle on B. So that's basically how it's coming out, and I've just added A and B to that. But what you'll see you're dependent on, as I said, you're dependent on getting object, and you need to filter to a surface, which is what I said. So I couldn't go in here and grab curve, say, and try and select that. It wouldn't allow me because the filter would be like, no, we're not selecting that. But once it selects that, it's going to take those surfaces, 1 and 0, 0 and 1, and it's going to find the U and V. And U and V is synonymous with 0 being U in the U direction, if you're thinking of local coordinate system, and think of your X and Y of the world plane, but you're thinking of your local area. And then 1 is going to symbolize the V. So then between those two, you're ending up generating these vectors that we actually could make them visible. And I think I did that after. No, I didn't. I probably should. I should grab those vectors, even though they're just angles. I should output my my vector normals right here as n0 and n1. And what I could do is, maybe I'll just do that for a second with n1. Let's just do n1. And let's just grab that out as a vector, which should be reading as that. Let me grab it. Vector normal, n1. It should be right. Oh, because I have to grab my surface from my other surface. And there we go. And now vector. Now there I should have a little vector, and with that vector I should be able to cut and paste this little amplification. So you always want to just, sometimes you can use the out to see if your code's working, but otherwise it's always nice to have an output. Just grab that, bring it over into vector, and take that as the start point to the anchor. And then of course these were deactivated, so we have to go in here and we have to hit enable, and we'll definitely want to go to preview. And there it is. You see the vector normal right there. Coming out at that point, which is an interesting spot for it because that's where I selected it. So if we go in again and we select surface 0 here and surface 1 here, there we go. We've got that, which I can amplify that vector and play with that in different directions as well. But that's the one angle that's created because of the two coming together on vector normals, and hopefully that starts to make sense. But then again, you're dependent on learning how to do a surface domain function, which we haven't learned yet, and you have to be dependent on finding a surface normal. And I think those are going to be very handy when we start manipulating surfaces farther on. So I'll leave that. I'll slide this one up here, and we will take that to disable, and we'll take those two surfaces and lines, which we don't need, and we will close that one up, and we'll go to the next one, which is actually vector scale. And vector scale is going to give us something, and I have a vector display as well. So let's enable that. Let's pull that one out. Where are you? Here we are. A vector scale function is pretty simple. It will take an x, y, z, and it will scale that. Now in scaling it, take a look at what it does to the scale. I've multiplied it by 10, but if I take it down to 1, what a scale does is it just moves it in that scaled factor and starts it farther along. So as I scale that, you'll see that that vector kind of jumps in that direction all the way down to 0, and then it quits when it gets to 0. So you got 1, 2, 3, 4, 5. It's moving up. And of course you can change the direction of that, and you can amplify that as well. And it's still going to be working off of its XYZ coordinates, and then it's going to scale in that direction. So hopefully that makes sense. You understand scale different in that way as opposed to what's happening when you're scaling with geometries. So kind of a nice little thing to think about. If you want to know a little more about that, then jump into the Rhino developer site and keep digging in for why things do what they do. But you're trying to understand things by visualizing, because they will give you more creative ideas of what to do. Take that to disable. We're going to run down here to vector length, and I've got a, and that's where I end with that other vector length I had. So let's close this one out, and let's take this one to enable, and we'll jump in here, and we have a script that is vector length, and I will have to get a point and then get another point, and then it will create a vector between the 2 points, and then I will output the length. And what happens is right here, get a point, get another point, and there we go. We have a little vector that jumped out here. Now probably this one would be more understandable if we go to the top view. So let me just go in here. Let's start here, make it a little smaller. And let's just grab another test. We'll start at 0, 0, and we will use a grid snap, which is why it was on. And I'll go here, and you'll notice it blasts out this way and finds the 1.41. If you think about that, you think of this as root 2. It's kind of interesting to think about that as a length as you go from 1 to 1. And so you start to think of vectors that way, and they start to move in the directions that they are. If we take point 2 to point 1, and let's run it again and do the exact same thing here and here, you're going to notice that it jumps in this direction. So we altered that. I just got a little girl coming here for some popsicles. So that's how you can start to play off point 1 to point 2 in church. To think of the lengths and the distances, and then you, of course, can amplify it in that way from that base point. But what's nice is you're really dealing in root 2 as it steps off and goes from that anchor point. And I could grab I guess I could grab another anchor point if I wanted. Anyway, so what I did with that is I'm just going to close that out and take that one. Of course, it wants me to find another point. There we go. And then I can close it out. That's one of those cases where it actually runs the script when you try to close it. I'm going to disable it, and then we're going to come down to this last function that I did, which is where we started. I think it's a pretty interesting one. And we'll jump back into all views. Which are interesting. We'll make that one enable it. And you can see how that does become a pretty interesting system of curves. So what is happening? How was I starting to think from just using the vector length tool? Well, I actually went in and I wanted to gather a list of vectors. So I wanted a list of things. And I appended that list with the vector list, which I generated in the exact same way, but I also amplified it by its I and range A, which allowed me to plug in, if you take a look at this, it allowed me to plug in A, or I could send it to B, or I could send it to C. And then I also generated 2 points at the start, here and here. My daughter's getting a little crazy because she just is hungry and wants to eat candy. So you can see where these points are being generated here and here off of my ABCs, and then a line between them I thought would be the best axis, because I'm basically performing a rotation through a range of pi. As we take a look at this, you'll see here I can have pretty good control, and that's really where it gets exciting. And doing that, and also what's interesting is as I change these, I'm still doing that bake with that add point. So you can see I'm still getting those points generating, so I can trace a history of this and still have a baseline, which I'm still considering what that means creatively for me. And that's where things, you can take the most basic scripts ever and start to complicate them and start dealing in lists, and then things get more and more interesting. And of course, I'm just visualizing those outputs. So this will be the file that'll come in the vectors 2, and I'll take all those and basically just group those. And we can anticipate in a little bit more time as I close that out. I am going to be going into point line surface nodes, going from add point add points all the way through the add sweep 2. Then I'll go in and I'll do transformations. And a lot of people say, well, what's the point of this? I mean, you're basically given micro plugins for every single one of these things, which happen to be the nodes in Grasshopper. So I'll move my ugly face down here. And so you've got all these things that are here. But the thing is, you want to know more about those maths. And just like Rhinoscriptsyntax is kind of just giving you the function that works that node, you're slowly, if you have an interest like me, you're going to want to break that down more and more and more. And you're going to want to go farther and farther into Rhino Common namespaces and discover what makes those functions. Because when you realize what makes those functions in Rhinoscript, then you realize you're writing in Rhino Common namespaces and you're learning how to write what's in those nodes. So whereas most people I find, you can see I was thrilled by it for a while, downloading every plugin I could imagine, that kind of streamlines you into a certain way of developing and making, be it what those plugins tend towards helping you with. Could be boat design, could be engineering, could be jewelry, could be anything. But I think, obviously the developer out there, a developer like me that has an interest, I'm coming at it from my own research. I want to understand things fully. I'm very excited about gaining control over points and vectors to know how it could then be applied. And it's that type of understanding and being able to wrap my head around that, like this one, in and of itself, as I take that and roll that through a quick little animation, which I did at the beginning. You see that makes a pretty cool thing. And even though it is just point line, it's doing a pretty interesting little subtle twist as well to gather those up as lines, as vectors, and lock those. You're going to follow some pretty beautiful forms. And I think anybody that's played around with recursion and iterations and fractals and likes all those patterns in architecture or anything they're doing, you're basically able to do that within the Ghpython node. And I guess if I ever get proficient at it, then I'll dig deeper into C#, and I'll go further and further. And who knows, I might actually make a plugin somebody really wants to explore beauty and experimentation in. Anyhow, another 22-minute video. Thank you for watching. I'm definitely going to produce this. We will now take that one and save that, and we'll save the next one as vectors. Actually, before I save it, I should see what I'm going to do. I'm going to call it point line surface geometry. I'll just call this one geometry. So as I go in here and hit save as, we'll just do a little geometry 003, and we'll start the third file in this set for my GitHub as well. So that's it, and we're ready to go, and we'll take a little save on that, and we're ready to jump into the first node's add point, see what we can come up with, and that should be pretty fun. So I will basically say goodbye.